Today we're going to look at the physical processes and the coastline and how the coastline is shaped by these particular processes. Now what we're going to do to start with is we're just going to have a quick look at this image here. So this is an image of a bay. We can see a sandy beach, we can see cliffs, and there are also some interesting features within this image. So where we can see this headland that sticks out with an arch at the end of it. And what's interesting here is thinking about how this formed. How did this arch actually form? And why have we got a beach sat behind this big headland that sticks out? And this is all down to physical processes that naturally occur in the world around us. So what we're going to do in this session is we're mainly going to work through, firstly, the physical processes that affect the coast and explain how those physical processes can lead to the formation of structural features like that arch. So we're going to start to think about the key processes that affect the coast. There are three groups of processes that we need to be comfortable with. And we're going to hit on these in a minute. Now, what you might remember in the last video, I asked you to look at these images, these particular processes just here, and find images and descriptions to back up your understanding of what these actually are. Hopefully you did that, and what I'm going to do now is I'm just going to kind of work through each of these particular processes and just try to explain what they actually are. So the first thing we're going to do is we're going to start to think about physical processes as a whole, break them down into three key categories. And these essentially are wind, wave, and tidal action. So the wind, the waves, and the tides have an impact upon the physical land mass as we know it. And they can act in two key ways. They can be constructive or destructive. And what we tend to find is that where something is being destroyed by physical processes, that destruction will lead to the construction elsewhere. Land mass doesn't just generally disappear completely. There must be some kind of process by which land mass and that bedrock is being broken down and it gets deposited elsewhere. And we're going to have a look at that process for a number of different examples in this video. Okay, so to look at wind action first. Wind action generally shapes what we know as loose material. So generally, wind will shape sand and soil. It can have a small impact on smaller kind of bedrock or small rock as such, but generally it's sand and soil that gets affected by these three key processes. These three key processes are abrasion, deflation, and saltation. Abrasion is a little bit like sandblasting. So this is where particles of sand or small stones, rocks, soil gets picked up by the wind and is carried and smashed against a hard substance like a rock, for example. This is shown in the image in the bottom left, the rock being hit with the sand, and you end up with a polished, flat surface. And this is a form of erosion that we need to be comfortable with. Deflation is where wind removes the loose particles from a surface, picks them up and moves them elsewhere. Deflation can cause dips and grooves. It can actually also lead to the formation of sand dunes, where you have peaks and troughs within the sand, and it also leaves behind larger rocks, as you can see in the image in the middle. Saltation is a process by which particles are moved over a surface by a fluid. Now, saltation can actually happen in wind, so wind can move small particles gradually across a headland or a beach or a bay, and it can also happen in water. So we do find saltation does happen in rivers, so particles can move down a river gradually. You can see this is where particles are lifted up and then drop back down a bit further downstream. And this happens over and over and over again. And as this happens en masse, you might get a build-up of sediment or particles further down the line. So that's wind processes and wind action, and how they can be both constructive and destructive. Next up, we have wave action. Wave action can act in a number of different ways. I'm going to highlight 6 key ways in which waves can act. The first is attrition. Now, attrition is what we call gradual wear down. Okay, so this can be seen in the image at the bottom left, where we have pebbles that are rounded and smooth. These pebbles may at some point have been rough, quite sharp in places, and they've rubbed together over time. And this could be because they're on a seabed, they could be on a shingle beach, they might be on a riverbed, and there's been wave action that's been moving these rocks, gradually rubbing them together, a little bit like if you were to sand something down. And then as the rocks rub together, attrition happens, and this is a form of erosion. The next one, number 2, is what we call corrosion. So corrosion is chemical wear down of rocks, and this happens where you have a weak acidic seawater that hits perhaps a headland or a cliff that's made of a more alkaline-based rock, so maybe limestone or chalk or something like that, and the reaction between the two leads to a breakdown in the cliff, and this in this image in the middle is leading to a notch forming, which can then also lead to landslides and further erosion through other physical processes. The third one was covered in the last video where we talked about the Dover cliffs, and we talked about hydraulic action. So this is the action of moving water on rocks, and it's perhaps the constant smashing of the waves against the foot of the cliff, breaking that cliff down into smaller and smaller pieces. This can also happen when you have rivers or streams or waterfalls, and the water running over a rock can lead to the wear down of that bedrock, and it can lead to the formation of valleys, canyons, or kind of other kind of features that you might find. So water, in terms of its hydraulic action, is where the water is moving onto the rock. Number 4, accretion or deposition. Essentially, this is where you have a build-up of a material, and this generally is due to wave movement in the form of a strong swash. Now, a swash is where the wave moves up the beach. So the waves come in, and as they come in, they carry materials, sand with it, and it deposits it onto the top of the beach, and then you get what we call a weak backwash. So the weak backwash means that the sand is deposited on the beach, but it's not removed. And this is a constructive wave pattern. Okay, so this is where we get build-up of a beach, and you can end up with quite a shallow beach. So what you find in this case is the slope of the beach is quite flat, and these beaches can go out for miles and miles and miles. So you might find this in places like Whitsand, Constantine Bay in Cornwall, and there'll be other examples that you might be able to think of where you have these very big beaches that go out for a long way when the tide is fully out. The next group of wave actions first is number 5 is erosion. Erosion is the opposite of deposition, which we just talked about. This is where we have a removal of material, generally due to a strong backwash. So this is where material has been deposited in the past, and we might get a situation where the waves move out faster backwards than they moved in. And what this does is it drags sediment with it. Sediments and sands are moved back, and you end up with quite a steep beach in this particular case. So you'll end up with this can also happen with shingle as well, and we do tend to find that this particular process does tend to happen when we have big storms that come in. Big storms come in, you get a strong backwash, and it pulls the sediments off the beach. You end up with very steep beaches that are left behind. So that is the opposite of the process that we looked at in number 4, and it's very much destructive. Number 6, longshore drift. Again, is something that you might have heard of. I'm going to talk a bit more about this in the next video, because we're going to start to think about how key coastal features are formed. Longshore drift is the transport of material along the coast due to a prevailing wind. So prevailing wind is shown in the 2 images at the bottom, where you've got the arrow that's out at sea pointing towards the northeast. And this is the general direction of the wind. And what we find in this particular case is that the wind pushes the movement of waves generally east along the headland, and it moves. What you get is a swash and a backwash that moves in a zigzag pattern, and it moves things to the east in this particular case. Now, as we can see in the bottom image on the right, the direction of movement is along the mainland towards this headland, and then you end up with something called a spit forming, and this is where sand is being deposited into this spit formation, and this on the right hand side is what we call a constructive process, and that sand will have had to come from somewhere else. So in this bay in front of the mainland, this would have been destructive. So destructive process leads to a constructive process in this particular Okay, so we're going to look at this in more detail in the next video when we start to look at the formation of spits, tombolos, and lagoons, and also bars as well. So we'll get to that in the next video. The last group that we talked about was the action of the tides. Now, tides act in two ways. They ebb, which means they go out, and they flow, which means they go in. And the movement of tides can also cause both accretion and erosion. So that means build up and breakdown as such. This will depend on the area we're looking at, what the substance is that you're particularly looking at. But what we need to realise is that tide currents, perhaps that flow when the tides go in and out, can cause both constructive and destructive patterns and build-ups, depending on, is the water being squeezed by, say, two headlands and it makes that water move faster, or is it quite open? And it depends on the way in which the water flows. And the image below just shows the way that tidal currents can move, and it does show areas of accretion and erosion, certainly on the right-hand side of the image. Okay, so that's the ways in which the three groups act upon the land as such. Okay, so what I would like you to do next, you're going to need to pause the video properly and take note of this task that I'm going to ask you to do. It's just to answer the following questions. Just do a little bit of research, a bit of reading. Just try and get your head around what I'm asking you to do. The first is essentially to think about how physical processes impact upon sediment size. So what I want you to think about here is what determines the size of the shingle on a shingle beach, for example. Do we have large boulders, say this big, or are they kind of this big? What processes are impacting upon that? What I'd like you then to think about is how the following geomorphological structures form. So firstly, headlands and bays. So how come we get headlands and bays? What causes that to happen? So sometimes you might find where you have a bay, you'll have two large headlands that stick out into the ocean. Why is that? Why do we have that formation? So have a think about that. We looked at wave cut platforms in a previous video, so do go back over that. Maybe think about the action of hydraulic action, the impact of temperature and precipitation on the formation of a wave cut platform. Caves and blowholes, I'd like to have a look at those two. How they form. Why do we get caves? There's lots of caves around the Cornish coast that you could look at as examples. Sea stacks, and also what you might include with sea stacks is the sea arches, like the one that we saw at the beginning in the image at the start. Think about why do they form and how do they form. Sand spits, tombolas, and bars, so that's going to relate to your longshore drift that we talked about earlier. So just have a think about those. And then the last one is just think about how do physical processes affect the profile of a shoreline. What do I mean by the profile of a shoreline? What I mean by that is, whether a beach is shallow or whether it's steep. So when you look at it side on. And remember, we talked about that idea earlier about constructive and destructive wave patterns and the way that the swash and the backwash can either lead to depositing of sand or the removal of sand. And that's going to give you the key answer to that particular section. Okay, so that covers this video. Hopefully you've made some good notes on that and you've got some ideas as to what you need to do for this particular task. What I'll do in the next video is I'll work through those particular geomorphological structures and we'll talk about how they form, and then I'm going to start to think about getting you guys moving on to the assignment and what you are going to be needing to do for that. Okay, so until next time, goodbye.